I would like to introduce Davide Rizzi. He's the application engineer in Turboden for large heat pumps. So for industrial processes and also district heating networks, he's actively involved in different development projects and also supports, the whole Turboden team for the industrial decarbonization in this area. So Davide has worked, started his career in Turboden as in energy efficiency projects in the oil and gas sector, especially in North America and also Middle East. So he's a mechanical engineer from the University degli Studi di Brescia. Davide, now it's your time for Turboden.
Okay, so thank you very much for the introduction, Cordin. Thank you very much to Cordin and to your colleague for involving us in this webinar. Today I'm giving you, let's say, 4 points of my agenda. So I will just briefly introduce Turboden company, who we are and what we do. Then we will go through our heat electrification portfolio. Then focusing on our steam compressor portfolio, or MVR, whatever we can call them. And then last and not least, I will present you our reference that was recently started for a steam generating heat pump of large size is in an industrial environment. So starting from scratch, who we are, Turboden, we are a technology provider, a global company. We are based in Italy, but working worldwide in more than 50 countries, basically from North America to Australia, with a strong presence in Europe. We are a company that produces technology, especially power plants. So we started our business providing and producing organic ranking cycle power plants, so organic turbines for power generation, meaning waste heat recovery to produce electric power. And then recently, since 2018-19, we extended our portfolio also to the heat electrification solution, which for us means the heat generation. So how to electrify the heat production for us means heat pumps for hot water production or MVR. So this is in a nutshell what our company is doing. We have more than 450 plants worldwide. Most of them are power plants for ORC, but we already have 2 references of heat pumps with 2 units installed with an overall capacity of 18 megawatt thermal power. Our company, is part of a large group. So Mitsubishi Heavy Industries owns the major share of Turboden, meaning that since 2013 we belong to this Japanese group. And Mitsubishi is a quite large industrial conglomerate. They are active in a lot of applications, so from nuclear energy to energy system, aviation, logistics. And Turboden has been placed in the GX, that means green transformation solution energy domain, which means that we are the company that is in charge to provide clean heat, so heat decarbonization, and we are a company that Mitsubishi is focusing within their heat electrification technologies. So moving to our heat pump portfolio, you can see from this slide actually that as I was introducing before, we do have 2 main technology, the heat pump and the MVR. Here are referred as LHP and MVR, is just the acronym. And in terms of area of application and sizes where we work, if we look to the graph on the top right, we can see that we can propose a solution that basically goes from 5 megawatt of thermal power, discharge the condenser, up to 50-55 megawatt per single frame. Then in terms of temperature, we can start for heat pumps from 80 degrees C onward up to more than 250 degrees C if we are referring steam. And I think that referring of steam is better to talk about pressure. So we can provide solution up to 30 bar G steam if we are coupling a steam compressor to our heat pumps. Our portfolio is basically composed by customized solutions. So we do not have on-the-shelf product, but we do the plant, because up up to a certain over a certain size, and heat pump becomes more a plant than a package. So we can design the plant together with the client and tailor-made the solution. So this is actually what we are working in the sizes. So giving some numbers our solution. Regarding the compressor portfolio that we can provide, I mean, it's very pleased to be within this audience, and all of you are aware about heat pumps in both technicals and applications. So here everybody knows about how the compressor is important within a heat pump, so which is the core of the system. So regarding the compressor that Turboden can provide, basically we can start from the right of this slide. We can equip our heat pumps with Mitsubishi heavy industry compressor, meaning large compressor typically meant for process industry. So for very big size, I would say from 20-30 megawatt onward, this solution can be applied. Whereas in the middle, we developed a patented integrally geared compressor. Here it is called Turboden LHP hermetic compressor. Basically, in this case, we can propose for our heat pumps an integral gear compressor multi-stage designed to work with hydrocarbon but also with other fluid compatible. In this case, this system has particular features that are very tailored for heat pump application to working in closed loops. And then going on the left side, last not least, it is the mechanical vapor compressor, so steam compressor. As Turboden, we do turbo compressor, so centrifugal machine, integrally geared, and this let's say last compressor line that I was talking is the one we will focus on today. As you can see from these numbers that are just a brief description, basically Turboden can work in a very large frame of solution, because we can provide system that goes from 150 kilowatt electrical or mechanical up to 10 and even more megawatt of mechanical power. So with this mechanical power we can handle different values of steam flow rate and different frames. So within these numbers and range we can propose different solution, and I will show later on which are the type of steam compressor that we can propose. Typically, when talking about MVR, so if we are making a system that even can go under vacuum and recovering a low temperature heat source, we can handle down to 65 degrees C, meaning that we can handle evaporation at 0.2 bar absolute and then compress it up to the pressure required by the process. So this is the compressor portfolio. Moving to the characteristics of our steam compressor, let me first introduce our largest frame of steam compressor. Basically, this steam compressor or MVR, it is based on our Turboden typical compressor that was meant for hydrocarbon, still an integrally geared system, multi-stage. In this case, we worked to start from that platform to design a solution that was meant for the steam, so we can share part of the technologies and feature, especially about the hermetic and the sealing system. And this steam compressor is meant for medium large application. Indeed, we can start working from 1000 cubic meter per hour up to more than 100,000. So within this range we have different frames, typically of gear, and different width and length of impellers, but let's see that this is the largest frame that we can handle with. And specifically, as you can see on the graph on the top left, we can handle temperature raised per stage up to more than 20 degrees C, and this is possible thanks to the high head of our turbo stages, which are specifically designed for the project and also using special materials. So this is actually the range. Regarding the control, which I think is very important to speak, especially when you are dealing with industrial players, steam compressor has to be controlled to follow the process needs, and we have two types of control. We can get to the init guide vein, basically the guide vein at the beginning of each stage of compressor to value actually the flow rate, and then the speed. So we can keep the system with a variable frequency driver to precise modulate and the control. So this is actually what we are doing in terms of the compressor. And last not least, as our know-how and typical activities is plant design, we can, other than just supply the steam compressor, we can provide the overall package, so even the evaporator piping, so actually to provide the complete MVR system tied into the process. So we can have both solutions within our portfolio. So moving from the large size, we can go to the smaller size. Indeed, as you can see here, we are working on an innovative compact steam compressor. We still haven't defined yet the name, but we call it small scale steam compressor. And in this case, you can see that this compressor is meant to work with smaller flow rate. Indeed, we can start working from half ton per hour up to 2-3 per unit. It is still an integrated gear system, but due to the reduced dimension, to handle and comply with the belt pressure that we have to produce, we studied and installed high-speed motor to try to squeeze as much as possible the dimension of the impellers and increase the efficiency. So also in this case, we will have a platform approach. So we will have a couple of frames of dimension, and then the solution will be modular. The aim of this technology will be to provide an integrated solution, meaning that we will not have only the rotating equipment, but equipped within the system there will be already the evaporator heat exchanger and the piping in order to provide a complete and almost ready to plug MVR package. So also in this case, as our know-how on centrifugal machine, we equip the system with IGV and variable frequency driver to precise modulate the performances and the operation. In this case, it's worth to mention that we are testing our first pilot within our facilities in Q1 2026. So, I hope that in the next phases to be able to provide you more information on this novel technology we are providing. Then, still keeping on the MVR side, last not least is a solution that has been developed by Mitsubishi directly from Japan called SGHP, or steam generation heat pump. In this case is a completely different approach. You can see from the drawing below the compact dimensions of the impellers and all the casing. In this case, Mitsubishi is designing a system that is based on automotive design with very high speed rotor architecture that allows to keep high compression ratio, but by minimizing the footprint. So the solution allows to rework in small spaces. And in this case, you can see from the graph on top left that the sizes in terms of flow rate that the system can work with are quite small. Indeed, can go from half up to 1 ton per hour. And as of today, the system is meant to work from half bar up to 3 bar, achieved in 3 stages. And then we are also working with them to increase the outlet pressure. So this system is another technology that we have within our portfolio as part of Mitsubishi Heavy Industry Group. So this is to conclude on the, let's say, portfolio of solution. In terms of capabilities of our company, here you can see some picture about our facilities where we do produce and also test the compressor. On the top left, you can see the prototype of integrally geared compressor working for hydrocarbons that was produced and tested in 2024-2025. That is it in our facility. This compressor has then been dismantled to be substituted with a new one that we are testing, and you can see the ranges of solution that we can test. We can test from power range from 300 kilowatt up to large frames with different, even different fluids. So regarding the technical figures of the compressor that we tested, it was a semi-hermetic design with a two-stage overhang system that allows to test multi-stage solution. So this test has finished with positive results, and then we are testing we are preparing for the test of the steam compressor in Q1 2026. Regarding the applications of steam compressor, I think that also the previous speaker already touched those points, and this is good because it means that we are aligned and there is a real need within these sectors. So we see application for steam compressor both for only heat pumps or heat pump plus MVR in chemical and petrochemical industry, in food and beverage, pharmaceutical industry, pulp and paper, wastewater treatment, and last not least also the combined heat and power plants where jacket water can be valorized by using either a heat pump or a steam compressor because the level of temperature of evaporation is still good in order to allow good efficiencies. So let's go as a last part of my presentation to the reference case of the steam generating heat pump that we have. We are in an industrial field, so we are talking about an heat pump in a paper mill in the North Europe. In this case, you can see from this very simplified scheme that the heat source is a wastewater coming from the paper production that has an average temperature in the range of 17 degrees C, that it is then cooled down around 8 degrees C. Those are the average. In summer could be a bit higher and in winter a bit lower, whereas the needs of the process is 170 degrees C, meaning 3 bar steam superheated with a return temperature of 100 degrees C. So the system is sized for 12 megawatt thermal power, and that means around 20 ton of steam per hour of superheated steam delivered directly to the paper process. So the system is composed by a two-step. So we do have an heat pump that takes from 8 degrees C to produce 1.5 bar absolute steam, and that steam is then sent to a two-stage steam compressor that produces the output required by the process, and the working fluid for the heat pump is natural. Indeed, we use the isobutane. The overall COP is 2 as an average. Due to this large delta temperature to comply with is still a good achievement, and then varies according to the process parameters, but still the average is 2, so is 2 times more than a traditional electric boiler that we could compare to that. So just to give you an overview about how the system looks like and to the magnitude, you can see within the picture some people to give you the idea about how big is this system. Basically, this system has a huge dimension related to the fact that as we have to recover very low temperature within the surface for the heat exchanger, and then volume for the steam produced on the steam drum, and you can see actually on gray, on metal color, all the heat exchanger, and in blue the compressor, which is a two-stage horizontal split compressor from Mitsubishi. So this is the 3D, very clean. Whereas let's see from the reality how the system looks like. You can compare the dimension of an heat pump to a truck to a crane, and you see the placement. So these are the phases of the project implementation installation. So we were in the middle installing the heat exchanger, and then we placed the steam drum. So quite a huge component to reach to these dimensions. On that side, we can have an overview about the compressor. Even though it's a huge system, the compressor is still a small part compared to the overall plant, but this is part of the erection. The plant is now operating since this summer, and we are finalizing in these weeks the acceptance test to then reach the commercial delivery. So it will be a real commercial reference and worldwide the first on its temperature level and also size within this application. This is the let's say an overview from the top of the system. It is quite complex environment of piping because we had a constraint in terms of space available, but this is the challenge of making engineering. So every time we have to adapt to a site condition and design the system based on client purposes, and this is what we do, and I think is a good achievement to share. And last not least, you can actually have an overview. This is just a screenshot about a week and even a bit more of operation, where you can see the evaporator water flow, the temperature of the evaporator, the steam pressure. So in this case, we were running at 18 ton per hour at 2.3 bar, and the COP, you can see that sometimes has some, when the temperature of the evaporator drops, we do have a higher consumption, but then steady state, the COP is in the range of 2. So I think I was a bit over time for that. I thank you for your attention. There is pasted here my email address, so if I cannot fulfill all the questions on the chat, just feel free to drop me an email and we can do discussion later. Thank you very much.
Thank you very much, Davide.